let's have a look at scientific notation. So scientific notation is sometimes also called standard index form, and we use this when we've got either really large numbers or really small numbers, and we do this to write in a tidy way. So for example, on our calculators, the screen itself, if you look at your actual calculator screen, there's a limited number of digits that it can display across the screen. Same in programs like Excel or Google Sheets. In each cell there is a limited number of digits that it will show. So this is a very useful notation, and it's used quite a bit in science as well. So the key thing is that we have some number itself, okay, so we have this value of C, and that is being multiplied by 10 to the power of something. Now it's always going to be base 10, and that value of n has to be an integer. Alright, now we want to have at least one digit on the left hand side of the decimal points. So let's show you an example of what I mean. So for example, 5.2 times 10 to the power of 3, it's got a 5 and then it's got the decimal point, okay, and then it's got 10 to the power of positive 3. That is a standard form. Whereas this one here, 52 times 10 squared, it's the same number still, but it's written 52 times it, and we don't want it that. We want it always as number dot whatever times 10 to the power of some other number. Okay, this one, the next one here, 8 times 10 to the power of 9. There's our decimal point straight after the 8. We don't write it, but it's there. And same with this one here, 4.391 times 10 to the power of minus 1. So we can have positive or negative powers. So if I've got a really large number, like for example this one, so that is 560 billion of something or other, okay, maybe I'm talking about the number of bacteria on a plate, I can write that as 1.56 times 10 to the power of 12. All right, so they're both the same number, it's just writing it in a different way. So let's have a look at some patterns, and I want you to think about this set of numbers here. 10, 100, 1,000, 10,000, 100,000, million. Let's think about what's happening. So if I take the number 10 in expanded form, I could write that as 1 times 10. If I take the number 100, I could write that as 1 times 10 times 10, because 10 times 10 is 100. And I'm just wanting to put it always as 1 times something, so it's in the same form. 1,000, 10 times 10 times 10. Okay, 10,000, 10 times 10 times 10 times 10. So you'll notice with all of these, we're always multiplying by 10, but we're multiplying a different number of times. So in scientific notation, I would write the first number as 1 times 10 to the power of 1, because I've got 1 10. The next one I'd write as 1 times 10 to the power of 2, and that's because I'm multiplying by 10 twice. If I extend that now to the next one, I'm multiplying by 10 once, twice, 3 times, so that's going to be 1 times 10 to the power of 3. Equally, the last one there, 10 times 10 times 10 times 10, I'm multiplying 10 4 times, so that is 1 times 10 to the power of 4. Alright, so each number is just increasing in the number of times it's being multiplied by 10. Alright, so that's what that scientific notation means, is how many times you're multiplying 10 together. Equally, very, very small numbers, so small numbers will have a negative power, okay? So big numbers have a positive power, small numbers will have a negative power. So let's think about this pattern of numbers now. So this pattern 1.1, 0.01, 0.001, etc. Let's think about what's happening. They've all got the same digit of 1, but the first one I'm just multiplying by 10 to the power of 0, because hopefully you remember from our power rules that 10 to the power of 0 equals 1. Okay. If I do 0.1, that's the same as 1 times 1 over 10. Alright, so 1/10, because that's my 10th column there. That's my 10th column, 1/10, and 1 over 10 is the same as 1/10. If I do 0.01, 1 times 1/10 times 1/10, because that will give me my hundredths column. Okay, 0.001, 1 times 1 over 10 times 1 over 10 times 1 over 10. And the next one, 1 times 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. So if you notice the pattern, what's happening now is that we are multiplying it by 1 over 10. So if I'm multiplying it by 1 over 10 once, then that would be the same as 1 times 10 to the power of -1. If I do the next one, I'm multiplying by 1/10 twice, so that will give me 1 times 10 to the power of -2. The next one, I've got 3 lots of 1/10ths, so that's going to be 1 times 10 to the -3, and the last one, 1 times 10 to the -4, and the very first one, 1 times 10 to the power of 0. Alright, so what I want you to think about there is these patterns of numbers that you're seeing. Now let's think about converting these numbers to scientific notation. So if I take the number 29, I want you to think, well, where is the decimal point? And at the moment, the decimal point would be 29 point something or other. Okay, so that's where the decimal point is. We want to make this number into 2.9 times 10 to the power of something. All right, so I want to move that decimal point over once to the left. All right, so that's what I want to do, is I want to move once to the left. All right, so because I'm doing that, it's a large number, it's not a small number, it's not a decimal number, so we're doing positive powers. I'm moving it one space, so that's why it's going to be 2.9 times 10 to the power of 1. I'm moving it one space. Now we do the same thing for the next one, 600 million. Okay, so the decimal point at the moment would be after that million. So I want to move that decimal place 1, 2, 3, 4, 5, 6, 7, 8. So I want to move it so it's between the 6 and 0, because I want to have 6.0 times 10 to the power of something. And in this case, I'm moving it 8 to the left. So that means in standard form, 6.0 times 10 to the power of 8. The next one, now I've got a decimal number, so now I've got a small number. So now I need to think about it in terms of a negative power. So let's think, where is the decimal point at the moment? Okay, so there's our decimal point. And let's think where I want to move that to. I want to move that so it's in front of the 9. So I want to be able to write 9 point, it's anything, or just 9, times 10 to the power of something. So in this case, I am moving that decimal point 2 spaces to the right. And so that means I'm going to move it negative, the power of -2. Last one here, 0.0, so there's our decimal point there, 0.000502. I want to move that decimal point to be between the 5 and the 0 there. So I want to be able to write this number as 5.02 times 10 to the power of something. So I want to move that 1, 2, 3, 4 spaces. Okay, so I want to move 4 spaces to the right. So that means my power is -4. And there we go.